One thing important is, if you see the lower right side of the slide, MES has many modules, because whatever a shop floor manager is supposed to do, either it is PPC, production, maintenance, quality, right? Everything has a module in MES. These are customized solutions. These are solutions to help you kind of make a system-based approach out of your routine activity. Whether it is quality, whether it is genealogy, whether it is labor management, what kind of skilled person can work on which station, this can manage that if you make a database out of that. Which machine can produce what part, this can manage that. Maintenance, when does a machine need a maintenance, it can call the maintenance people accordingly if you set the number of cycles. What spares went into which machine, this can update into the SAP, right? This, some example I'll give you. Suppose, for example, there is a person on the sales side sitting at a customer end. He wants to know where is the ordered material at this point of time. This system can give him authentic data, and he can increase the customer value by talking to him that, yes, this is where your thing is, and in 2 days it will be delivered to you, right? Quality management. I have an example. I'll just share that slide with you. There is a company in Kolhapur in the foundry segment, and these people are manufacturing pistons. So as the environment changes, right, the recipe or the control parameters changes, right? They were managing their show without these systems, and they were having high amount of rejections. Now with this system, they have created around 14 recipes of various temperatures and various die temperature or the environment temperature or the pouring speed or other kind of things. And as soon as a system, as per the parameters, they load the recipe at a touch of a button, and the first piece that comes out of the machine is an OK piece. There is no setup time change. There is no rejections, right? So this is the power of these kind of systems, the intelligence of the shop floor. Traceability is becoming an issue. When was this made? Product recalls and other things are going to, this is the reality. I mean, we're getting a lot of inquiries from the marketplace that traceability is an issue. When was this made? Who made this? How much was the bad lot? How do you track it? How do you take immediate action? How do you contain the defects? That is enabled by this. Which parts went into the main subassembly, right? How do you marry the child parts to the main body through barcodes or through RFIDs? Tools are just enablers. Main is the solution, right? If you see on the left side, lower side, these are levels as per ISA 95, which is the standard architecture for an MES solution. Level 0, level 1, every company has. They have to have machines for manufacturing. Level 2 are PLCs and SCADA systems for basically controlling these machines, which some of the companies have. Business system every company has, because they need to manage. Business system is all about money and the invoicing and the orders, right? MES comes in between, which is also called the manufacturing operations management, which has basically months, weeks, days, and shifts if they are in the business system. This MES can give you data in shifts, hours, minutes, and seconds, right? It can control. And one example is that normally when at the start of a shift, the workers normally, the first hour has low production, right? But this system, since it controls on an hourly target basis, right? So that means that this system, the operator is aware that I am being tracked against a target and on hourly target. That means I have to match. As soon as we implemented a system at a place, their first hour production improved, right? So it bridges the gap between business system and the controlling system using IT as an enabler. These are some of the cases and the business benefits achieved through this technology implementation. You can see rejection reduced, setup type reduction by 80%. This I'm talking of this piston manufacturer. Workflow validation. You need to have a system-based approach. This is demonstrable quality assurance. When a customer of yours comes to your plant to see how you're managing your quality, this system at a touch of a button can give him that assurance that I will be getting good quality products for all times to come, right? Compliance, handling compliance, single system. The fourth case study is about an integrated MES. The whole company is running on MES solution, right? It has given immense immense opportunity of improvement for them. Even the third-party logistics, who's doing the kitting for that plant, is very happy because there is no chaos. If there is chaos, people are demotivated. There is no chaos. There is clear information in place. He is supplying the material as per clear information. He is very happy. He says, do this system at other places also so that my life becomes simple. The operator is happy. The third-party logistics is happy. The management is happy. Now I'll take 2 slides about ourselves, who we are. That was all about MES in this presentation. Who we are from the Tata Group, a subsidiary of Tata Motors. We started as a technology arm of Tata Motors. And then we started kind of working outside. We still work for Tata Motors, all plants from nano development. We were a major contributor in the nano engineering and design development. As well as we also work for Jaguar Land Rover, where all their IT applications and other things we manage. So we are a services company doing IT, business IT. We are doing engineering and design, started with there. We are doing SAP, ERP, and the other thing, and the PLM side of it. We are an end-to-end PLM implementation partner, right? We are about 376 million in revenue last year, presence in around 25 countries with 6,300 professionals and about 2 decades of experience. One important thing to note is that we are a manufacturing-focused company, and that's the right forum that we are here. We work only for manufacturing industry. All our top clients, we work for the top automotive, aerospace, heavy engineering clients and their suppliers. The top suppliers you can name, and that will be in our customer base. We are focused on manufacturing. All our people are from the manufacturing backgrounds. I have around 12 years of manufacturing. And similarly, people who joined Tata Motors as GETs are now leaders in the company, right? So these are the type of people in the company and the value that they bring. Below, we can see examples of innovation, the electric car that we developed on our own without Tata Motors. This is the example of our full vehicle development strength, the aerospace thing, and the benchmarking studies we do for the heavy earth moving or the industrial machinery segment. We touch the lives of manufacturing product development at all places, right from concept development to the supplier coordination, to the plant automation, to the digital engineering, with the thing that we showed earlier, the customer-facing solutions or the corporate planning solutions. So we are there everywhere, and we touch the lives. So that's our strength. This was all about it. I'll just summarize. One thing that you need to be cautious when you're implementing a manufacturing execution system, that the partner that you choose, solutions are many and they are proven solutions. The partner that you choose must have a manufacturing domain experience, because it's not about devising a solution, it's about knowing what is going on in the shop floor and kind of converting that into a suitable solutions. You must have an IT backbone, he must have a controls background. Solutions, basically these solutions suit your challenges. Every day you will be facing a new challenge in your manufacturing environment. These solutions convert your challenges into solutions. So we have an example of working at a Marathi, the control panel was all Marathi language, and in Tata Devo, Korea, all the panels were in Korean language. So this is the kind of versatility that is expected. We have experience of working with a small and medium enterprise to a large OEM, right? So that's the kind of thing. It can start, if you plan to go into this MES kind of solutions, you can plan small. It can have a pull effect. I mean, you introduce technology into the shop floor, but see that it is accepted. Once it is accepted, I mean, mobile phone came as simple devices. Now they are complex applications. It is the demand that we are creating for the technology. In that similar way, in a shop floor, let the operators or the workmen or the managers create that pull factor that I need these solutions. So then give those solutions. Start small and then make it big. Definitely they will see the value in this. Definitely the organization will see the value. Start with one function. I mean, there are many functions in a manufacturing execution system. Start with one function, then go to multiple functions. So in the end, basically what it does is it keeps the workman happy, because although he is basically working in a system-based approach person will always be happy because he does not have to face the chaos. He is basically, you are also de-skilling the kind of the work, because the machine guides the operator what to do, right? These are simple interfaces. We have touch panels or thin clients, basically, which tells or guides the operator what to do. No blame game, single truth organization, paperless, synchronized real-time reporting. There is one report in all the plant. Even the management can see at a click of a button on his computer, or the shop floor people can see that. Suppliers are happy because crisp information is available. Customers are happy because they get the real information and of what's happening and the assurance of a good quality product. Equipments are better utilized, right? There is a better asset utilization. The maintenance happens and there is a better throughput from your system. And for management, it is easier to align the business strategy to the control or the manufacturing strategy, and easier to coordinate various plants and operations. These systems can manage multiple plants, multiple operations, right? So for management, it is very easy to see everything on a desktop, that what's happening where, and kind of take corrective action when it is required, as soon as it is required. And in the end, I think this topic has also been covered. These are tough times, but customer expectations do not reduce. Only those who innovate will survive and grow. I think I'll close now. Thanks a lot.
Thank you very much, Mr. Saxena. I think you hit the nail on the head when you said there should be a single source of truth in an organization. Thanks for sharing us how technology can be used to make a meaningful solution and not just as a use of a tool or a specific system. Before we move on to the next, I'd just like to remind you about the lucky draw. I think you would have seen people, moving with the boxes. I hope you all submitted the little blue papers. We have the results announced in a bit. All right. The next speaker is a territory manager with the Asia Pacific BD group from Indo-US MIM Tech. He has been working closely with many of the global customers to help people migrate appropriate parts from conventional manufacturing to an innovative manufacturing method called metal injection molding. One of his responsibilities is to identify which parts and which areas will MIM fit in, and how we can migrate parts from the conventional to MIM method. I would like to invite Mr. Ashok Vardhan to take us through the innovative metalworking process and explain us what metal injection molding is all about.
Can you just disconnect it first? Display disconnected. Display disconnected.
Good afternoon, everyone. I know it's been a very long day of presentations from different people from different technologies and products. And I'm sure that most of the people are awaiting for this particular session, which is going to be a very interesting and very new technology for us. So without delaying, I think we have very less time, so let me take you through the slides little quickly. Without delaying, let me start to discuss about one of the innovative metalworking process. Okay. Let me start with a small example. Let's take, this is the component, which has to be manufactured using a conventional method of machining. Okay. You can see a number of processes which are involved to get the final and finished component, right? Okay. What if we can do this? Without having number of operations that are involved, if you can achieve the final component directly through molding, is it going to be advantageous to us or not? So what we are doing exactly here is, we are trying to chop off all the complex or the hectic, I would say, manufacturing procedures into one single operation of MEM. What is MEM? MEM is called metal injection molding. I'm sure all of us are aware of plastic injection molding and many other conventional process of processing a metal component. MEM basically we define is as marriage between two different technologies. One is plastic injection molding and powder metallurgy. We take shape-giving capabilities from plastic injection molding technology and strength-giving capabilities from powder metallurgy technology. So together it has been formed as MEM, which is called metal injection molding. So basically MEM involves 4 processes. One is compounding, second is molding, third is debinding, fourth is sintered, which is the final stage where you will get the finished component. What is compounding? So basically this process uses very fine metal powders, which are of less than 20 microns in granule size and are combined with binders and the wax content and made it into a feedstock, which is going to be an input for molding machine. I'm going to discuss more on this, like what exactly is this binder, why we have to use and all the stuff. And second is molding, where we give the shape to the component. Whatever the required shape or the final requirement is there on the component, we are going to give that shape at this stage. Third would be debinding. As I told, in the compounding, we are going to add up binders, which are basically carriers of the metal powders into the die. So once its role is completed, it's our next task to remove it off, right? That will be done in the debinding session. So once the binders have been removed from the component, now we have to give strength to the component, correct? That will be given at this stage of sintering. To have more understanding on the process, you can watch this small animation which explains more. Here is the compounding session where you are going to combine the very fine metal powders with binders and alloying elements, whatever required. So the one more advantage that you have with this technology is you can always make a material which is tailor-made for your application. It's not that, if there is a bar stock material which is not available, you can always, make your own specifications. And once the powders and alloying elements are mixed up, and wax and the polymers will be added up into that, basically that makes the powders to flow into the die. Here you can see the mixture or the feedstock has been made into granules, and is fed into the injection molding machine, basically to give the shape. So once the molding procedure is completed, we have to remove the binders. In this particular video, you will not be able to see debinding session separately, wherein actually there is one more stage of debinding where the primary binders will be removed off. It is basically a solvent debinding process and then taken for the sintering. If you could see, there is a shrinkage, from the molding shape or the size to the final part, which is because of the binder content debinding section. So finally, the metal powders are being converted into the required shape of a metal component. You can see the change in shape, like approximately 20% of the shrinkage from the molding to the final sintered component. So what happens exactly? Here you can see in the green stage all the feedstock which is been combined with the binders, which is removed in the brown part, which is in the debinding stage, and finally in the sintered part, all the molecules are brought together, giving the required density to the component. Here you can see much more closer pictures of molecules getting merged with each other, which is basically an intermolecular diffusion which is going to happen in the sintering stage. Why MIM? Okay. Why does this requirement occur? Here we go. As the complexity of the component increases, along with the annual requirements, MIM stands the best process. Because as we all know that, as the number of operations need to be added up to get the final complex shaped metal component, it has always been a challenging job in the manufacturing segment. So to cut down all the complexity and to produce a high volume components, MIM stands the best process. As far as the cost is concerned, again, as the complexity increases, unit cost comes down by using MIM technology. This is a basic comparison that I would give when compared to the powder metallurgy component technology. This we call it as an advanced version of a powder metallurgy technology, for the simple reason that the quality levels that you are going to achieve with MIM are going to be much more higher than the powder metallurgy technology. Because the basic density, as we all know, in the powder metallurgy, probably the density it is going to be about 6.5 gram per cc or something, close to that. But whereas in MIM, the minimum density you are going to achieve is going to be 7.5 grams per cc to 7.8 grams per cc, which is almost equivalent to your wrought material. Here we go, as far as the strength is concerned, there is no need to compromise on that. You are going to have an absolute requirement of strength on the component using MIM technology. And these are the typical materials which are processed through this technology. All kind of case hardened steels, through hardened steels, stainless steel, magnetic materials, heavy superalloys, tool steels, etc. So what basically MIM offers? Whatever the complexity that you can imagine in a plastic injection molding technology now can be imagined in metals using a technology called metal injection molding. Here we go, all kind of threadings or the knurlings or the complicated profiles, angular holes, everything can be formed in as MIM condition. So there is no absolutely there is no secondary operation that you are going to perform on the MIM components. So like our wrought materials, MIM parts are very much feasible for all kind of operations, like whether it may be machining or it may be a platings or special kind of coatings or surface treatments, welding, everything. You will have all kind of properties with the metal injection molded components. Okay, apart from the advantage that we have, also we do have some kind of a limitations for this technology, wherein when the part is falling in between 0.01 gram to maximum of 200 grams can be processed with this technology. And annual requirements, minimum it's going to be a 50K, and maximum we can go up to 25 million per annum. And length is, as mentioned, maximum length can be 200 mm of the component, and the wall thickness is of 0.5 mm to 5 mm maximum. So beyond 5 mm, we have an option of going for coring, which is basically removal of unwanted material or non-functional material on the component, which in turn gives an advantage of overall reduction of the overall reduction of the weight of the component, which is one of the most required properties of for automobile industry. So where does this MIM fit? It's not in one segment. Wherever you have a requirement of complex metal parts, MIM fits in that. If you take a medical, there are many applications in medical segment, like surgical instruments or your dental brackets that can be made. Anything which is complex in shape can be processed to MIM. In power tools, almost all the power tools are having more than 5 components developed for MIM technology, which are complex in nature. And as far as the mobile segments are concerned, I think most of us are aware, leading companies like Apple, Samsung, they are users of this MEM technology to a large extent. And automotives, we have applications everywhere, right from the tier 1, if you take turbochargers, we have an application of MEM, and if you take for OEMs, we have an application of MEM. So wherever there is a component which is challenging to manufacture through conventional method of manufacturing, MEM suits the best. So these are typical applications as far as the automotive industry is concerned, like seat belt applications, a turbocharger, interior, fuel injection systems, sensors, brake applications everywhere. Why in the MIM? Let me have a small, little details about our company as well. We started our company in 1997 with a joint venture with a US company, and later we became an independent in 2001. Also we have started our second plant in 2006, and as we grow, we have armed ourselves with many other facilities like investment castings or medical facility, which is ISO 13485 certified with Class 8 clean room, and titanium injection molding and ceramic injection molding. Basically, the objective is to have one-stop solution providers for the customers. So these are the 3 facilities that we have. The left you can see the facility which is located in Hoskote, and the second, that is dedicated for MEM completely. And the second one is in Dudbalapur, which is also having a facilities for aerospace machining and the special processes special coatings and all those stuff, along with the medical Class 8 clean room. And apart from this, we also have an investment casting plant located near Tirupati, which is completely dedicated for investment castings, where we go up to 25 to 30 kgs. So as far as the plant is concerned, it is completely an integrated plant. Only the powders that we are going to import, and rest of everything will be done in-house, right from the design of tool to tool manufacturing, molding, feedstock preparation, sintering, debinding, and even the secondary operations. Why I have mentioned secondary operations is, as you know, MEM is restricted to achieve dimensions of, as per ISO 2768 medium, and a thumb rule of 0.5% of the basic dimension. So beyond which, if you want to close the tolerances, secondaries need to be done, and we do have that in-house. So let me just quickly go through some of the case studies wherein MIM has provided a very good solutions for many of our customers of different segments. So here is one example wherein the component is being used in autos like adjuster of automotive of a vehicle, The original manufacturing process for this component was, machined, and here you can see, this part of it was, welded with this component. Both are machined separately and are welded together, wherein using a MEM we have integrated it completely and made into a single component. And this will fetch in, give you advantages like, there is no question of burr, absolutely, and you can go for any, any range of high volumes, okay, and lead time is very less as you compare with the machining. Here we go, one of the interesting case studies wherein you can see the fuel injection nozzle, which is having a diameter of about 0.5 mm, and the requirement of this component is about 200K every month. And I think, you can imagine if it has to be machined or, or any other conventional method, how tough it is going to be. Here is one more classic example of the value addition which Indomim has been doing for majority of the customers across the globe. Like the original component was being done in powder metallurgy, wherein the customer felt that the strength was not enough for, as far as the application is concerned, and was migrated to MEM. And by MEM, it's not only that the strength has been enhanced, but also the optimization of the design. You can see the reduction in the size, which has been done or redesigned the component by Indomim. And let me tell you one more thing, like the new component which has been redesigned also have an internal thread here inside, which is also made in ASMEM condition. So here is one more classic example where the integration is possible. So basically, this component has an application in printer heads. So the original component was having three components, like one this pin, the small pins, which was been welded, after making through through the machining route, which was completely integrated into a single component. So here you can see the type of components that have been developed through MEM. I'm sure, like you cannot imagine these components of this complexity in any other conventional methods. So finally, it doesn't matter what you design, we are here to help you out. So we call this technology as a treat for the designers, basically, They can just close their eyes and draw a sketch, we can make the component. So thank you.
Thank you very much, Mr. Vardhan. I'm sure it was definitely an innovation in the process and changing the way we look at how metal forming is done. We're moving to the last presentation of the day. We have with us a person who's a gold medalist from Indian Institute of Management, having started his career in BARC, Bhabha Atomic Research Center. He has filed 9 patents in his name. He has won business improvement competition in Bangalore and Vietnam as well. Currently in a role of a DGM in strategy management, he heads the strategy initiatives in Robert Bosch, Bangalore. Please join me in inviting Mr. Pranava Tripathi, who will speak about innovation and leadership and creating innovative organizations.
afternoon. Technologically superiority, this is just a matter of time. Today, what you see is giving you advantage, a leadership. Tomorrow, it may not do so. And the live example is recently what we see that Indian Post recently announced that discontinuation of telegram services. It was a marvelous technological revolution that shrink time and space in world of communication. Innovation is a must for a sustainable growth. And this presentation is going to talk about what an organization should do to be leader and how we are going to create such type of innovative organization. First of all, let me confess that in my career also, I misused what is called innovation. It's a buzzword. It's most often used everywhere, and nowadays every time. People talk only innovation, innovation, innovation. Fewer know about innovation and very few practice it. Yeah? So what we are going to do is that I will just define innovation in my words. We will see that how innovation is possible under extreme operational pressures, and how one organization can foster innovative culture. And then I will give you example of 127 years of innovation and leadership of Robert Bosch. So innovation, I think Mr. Banerjee was saying that how you can harness creativity, how you can channelize the creativity. The answer is innovation. Actually, the moment you are able to channelize creativity, that's called innovation. Here. Innovation is process of making your creativity and invention towards your company mission. Yeah. It need not to be money. But whatever your mission is there, your creativity and invention should be guided towards that. Innovation means brings your ideas to life. And how you can make this channel powerful? It's not only one directional, it's a both directional. You need to safeguard this channel of innovation by very strong market insight. You need to have the competitor analysis. You need to know your competitors. You need to know where innovation lies. And you need to know the technological trends which you can leverage for the innovation. This is the different view of the innovation. What it's required is understanding your user, your customers very well. You need to know about the technology, what is the feasibility in the technology, and finally, how you can make your products viable, economically viable in the marketplace. Actually, just before this session, we had a panel, and the discussion was happening about the failure, why we don't embrace failure. In a strong innovative culture, there is nothing called failure. Yeah? Because the aim or mission is not success or failure. Aim and mission is you achieve the result, and the result is very tangibly defined. Yeah? And I will give you example of two wonderful products which I really like very much in terms of innovation. First one is Viagra. Yeah? It was a medicine intended for blood pressure and heart disease. Yeah? And in clinical trial, it found to be not very effective. Yeah? If the success or failure has been the criteria for the innovation, then we have not seen the Viagra. In the clinical trial, when next day the patient came, they claimed that effect was somewhere else. Yeah? And the same thing happened with the Post-it. The research was happening for finding a very, very strong adhesive. And it failed. It failed miserably. It was not even able to stick to papers properly. And then, but the aim was not to make it successful. The aim was there to launch a new product. And then the managers there saw the possibility of the Post-it. Yeah? So in a strong innovation culture, there is nothing called failure. Everything conspired to give result. The question comes that how you can make this innovative culture, how you can harness the creativity. And for that, I will explain first the 4 mindset typically you find in one organization. The first one is the treadmill. And the symptom is that faster you run, behinder you get. You feel distracted because there is very fragmented work day. You have been shared across many projects, and your manager will say somebody was telling that manage something. And that word you will listen very often. The people are so busy in their work, they do not even understand what is the importance of their work, why they are doing this. They are asked to do so, and they do this. The second one is autopilot, where you have very low time pressure, but also creative thinking is very low. Here, this precisely answers to a very strong illusion that creativity needs time. In this autopilot setup also, creativity and innovation doesn't happen. They do not happen. Why? If you are sitting on the bench, you hardly get any encouragement from the senior management for doing something new. Because business is running as usual. Perhaps your importance is not there in that business. And we talk there as we. We talk in the groups. We should do. Not singly who should do. We should do. We should innovate. We should be creative. The targets are given for the groups and not for the individuals. And therefore, everybody try to prove himself or herself superior because there is a identity crisis. And you want to show yourself, then you lose the collaborative culture and it becomes highly competitive. The another type of mindset is expedition. Typically you find in the research organization where you have a very high creative thinking, but the time pressure is not there. The focus of that organization is mainly generating ideas. And they generate the idea, they file patents, they publish papers. But what they miss is they do not know the problem, what they are solving. Collaboration exists, but more with the individuals. And the final one is the mission. You live the mission. You do not get salary, but you still work. When you wake up in the morning, you feel to come to office. Yeah? And that's the organization I'm talking about. In such organization, one can focus on one activity for a larger time. And everybody believes that what he or she is doing, it's worth. It's important for the company growth. And everybody is positively challenged. They do next day something better than what they are doing today. The identity problem. So as Einstein has told that if I have to solve a problem in 12 hours, 11 hours I will spend on identifying the problem itself. And 1 hour I will use for making the solution. So the organization which lives with the mission, their main focus is identifying the problem And once they have identified the problem, they generate the ideas and solution for those problems. Here, it is not important that what is the mindset of your organization. That is not really very important. What is very important is that what should be the mindset of your organization. And you start living that. So you were not there when I was talking about that, your question in the panel discussion about that, how you can harness creativity. Yeah, that is the innovation process altogether. Somebody was talking about jugaad. Yeah, jugaad. Lots of talk has happened. Yeah, jugaad is perhaps invention. It is the result of crisis. There was need, you invent something. Kuch to jugaad kar diya ho gaya. Yeah. Now, what was missing there, as I explained, the backlink. You know how you can take your idea to meaningful result for you. But what you are missing here is the backlink. You are not able to safeguard your channel. And what you are missing there is the market insight. What you are missing there is that competitors' strength. And what you are missing there is the technological trend. Yeah. If these three things are fed to the Jugaad India will really be a very great thing. How you can harness creativity? Harvard has done some research and they says that you need 10,000 hours of subject matter experience to be called as expertise. And that results somewhere around 8 years of experience. And when I'm talking about experience, it's not doing the same thing every day, but having the breadth of knowledge and depth of the knowledge. So expertise is the first element, how you can harness the creativity. The second one is the creative thinking itself. You should have the mission mindset where people are motivated to be flexible. And the third one is the intrinsic motivation. I do not say it's motivation, I say it's always will. Why will? And why not motivation? Because there is opposite of motivation. Whatever is making you motivate, absence of that can make you demotivate. But when you work with the will, there is nothing called unwill or non-will. You work with will. So, confluence of expertise and creative thinking. We all are creative. Human beings are creative. Yeah? So, creativity is not the problem. What you need to bring into the organization is expertise and motivation. If these two things are there, then you will see how your creativity is channelized for the innovation. Breakthrough, radical, these are also buzzwords. These are myth. They come on the way. You cannot plan for breakthrough or radical changes. It will happen by itself. What you should plan for consistent innovation, even if it's small, even if it's incremental, go for it. But make it consistent. That's the key of success. How you are going to do that? First of all, you need to create the right corporate environment. It should start from top. There should be very visible commitment of the senior management. Your CEO, CTO should keep talking about that. And they should define what is innovation. They should not simply say we should innovate. They should fix the target. When I'm saying innovation, means 25% of our revenue should come from the new businesses. When I'm talking about innovation, in our portfolio, 40% products should be new products. Such type of target should be set. And a smart goal that forces innovation. Every department should have a very well-defined goal. Every individual should have a very well-defined goal. What she or what her department is supposed to do for the innovation. And the third one is the narrowly focus to cut competition. There are many people who may differ to this approach that you should be narrowly focused. Here I don't mean that you need to be myopic. What I mean that you have breadth of knowledge, but you focus on a very small or just identify a unique competitive advantage and work for it. And another very important thing is that for setting up the right corporate environment is you should invest. Somebody has asked that what SME can do to innovate. Big organizations have money, big organizations have fund. SME also has money. You put 1% of your top line, you put 0.5% of your top line, but do it. And that is what shaping up enabling structure. You should have a very clear separation between running the business and fostering creative activity. If you'll ask your man on floor to innovate, they may invent, but they may fail to innovate. Clearly identifying a sponsor and dedicated resource. And another thing is that avoid hierarchy, especially the people who are involved in the fostering creative activity. They should report directly to CEO or maybe vice president level. And reinforce your commitment by providing a good monetary incentive to employees. Strategic alignment, focus on new ideas. You should have a very clear direction to kill competitive advantage. And you should keep, especially for the large organization, you should keep your eyes open for the market requirement, especially for a very small players. Yeah? Because you never know that they may take the premium segment out of you. And somebody talked in the panel discussion about the deployment. Yeah? When you start investing in the technology, you need to have some proportion of your budget to invest in making go-to-market strategy as well. In Robert Bosch, there is a BES, Bosch Engineering Services, is defined that various processes for product creation. You see that how many processes are there, and innovation management is the core process of the BES. It emphasizes on systematic development of innovation, implementation of transparent role and responsibilities, and method and tools for generating ideas. As you see, there is a very clear separation between innovation management and product engineering. How you check that your innovation is really going well? So we have GATE approached. We do innovation on all the three dimensions. This is processes, product services, and business models. What we do is that it starts with the strategic goal, and from strategic goal, we define the strategic fields. And that strategic fields is fed as an idea request. So the gate 0 is where you define the target for the innovation. Then we have the strong team. We do the innovation workshop. We call experts. We call our customers. We call academic leaders. We invest money to generate the ideas. And that's a 2 days or 3 days workshop where we go to a separate place and we simply generate the idea for the given problem. And these ideas would be worked out and then filtered out and presented on the Innovation Gate 1, where few ideas would be chosen for the evaluation. And this evaluation will include that business field analysis. And finally, the one idea which will be chosen for the prototyping and product development. And then the last, that Innovation Gate 3, it will be taken for the product. These are the criteria for a good innovation culture. If you say that, yes, your culture is innovative, you must have these criteria that all associates understand the importance of innovation and they know the goal of it. Very important, you must have innovation goal very concretely. Innovation goal should further be cascaded and must further be cascaded for individual performance. Otherwise, innovation won't happen. Role and responsibility should be clear. Hey, you are supposed to operate this machine. So you innovate only for the process. You leave radical innovation to research guys. Yeah. So role and responsibility should be very clear that what is expected from you. And innovation is a subject of daily business. It is not that one day, once the innovation workshop will happen, we will only generate idea in that time. It's a continuous process. And another important thing what we do in Robert Bosch is that we align our innovation strategy with the customer strategy. These are the characteristics when to live the innovation culture. There must be budget. There must be proactive execution. You should have both number and quality of ideas. There should be willingness to participation for all the levels, starting from the juniors till CEO. There should be detailed evaluation of ideas based on the detailed checklist. These are the overheads, but you have to bear it. And employees must be honored for the new ideas and the progresses. In summary, innovation is needed to sustain growth and to be a leader. Innovation is possible irrespective of time pressure. These are excuses. And to foster innovation, it must start from the top. And we should have a very flat organization where ideas directly goes to the senior management. We must know the competitive dynamics. We must know that where really innovation is lying. And once you have decided the idea, invest heavily in that idea. And in Bosch, we have a matured innovation management processes. Thank you very much.
Thank you very much, Mr. Tripathi, for an insightful presentation on how innovation can be managed within an organization. The key points being in an enabling structure and the right nature of environment for innovation to prosper. And with that, we complete the presentations. Before we move on, do we have time for a couple of questions? Maybe we can take 2 questions for the 4 speakers. Or if you'd like to speak to the speakers one-on-one post this, that should also be okay. The speakers will be available. All right, just keeping time in mind, let us move on to the next part. Before we move on, I'd just like to remind you that there are feedback forms in the bags that you're carrying. We request you to please fill the feedback form and kindly deposit back at the desk as you're on your way out. All right, please ensure that you fill in the feedback form. We value your thoughts and your experience. I would like to invite Mr. Nirmalya Banerjee to summarize our day and look at what these 5 boxes or where these 5 boxes are headed. Thanks, Mr. Banerjee.
Very good evening, ladies and gentlemen. This has been an engaging session. So concluding in 2 minutes is difficult. I'm sure everyone has his own conclusion and her own conclusion to take the learning and how do they really implement. I'll try to take a macro view so that we have a general learning and kind of a structured thinking to culminate to make an effective use of what has been the investment of 1 full day from our valuable life. This was planned at a very perfect juncture. Many of the speakers talked about Indian industry is not doing that great, and typical reaction being more defensive, to be somehow managing the position that we are holding, not letting it go to the competitor. But that's the time when innovation can really create new areas. It can really open the new ventures which can really be leveraged in future. So very rightly planned, very rightly timed by CII. So this is the right point to really look at what innovation can do for us. It's not only manufacturing, we have the audience of manufacturing, but it can be applied anywhere, service industry as well as in our life as well. That's what we heard here from many speakers, what is happening in their respective areas of expertise and experiences. Now, when we take on something, there are basically 3 stages definitely it will go. I'm not talking theory, but in trying to generalize that. For taking up a new thing, new habit, or imbibing a new principle in an organization, first you require a conviction. Yes, we would like to go for that. Unless there is a conviction, nothing will happen. So I think the conviction has happened. This session has provided the conviction with leaders of the industry sharing their conviction, sharing the direction, and giving the motivation to the future leaders here that, yes, that's the way we need to go. Next stage comes the confidence. Confidence is we have a conviction, but we do not know how of that. So that has really happened with a lot of learnings from a lot of leaders, a lot of industry experts with their experiences. We looked at different ways that it can be really leveraged. We talked about the creativity which is innate in Indian environment, which is innate in Indians, and which is innate in the way we are brought up in Indian context, and which is innate in the culture that we bring up, with all the shortcomings of maybe a discipline issue, maybe government red taping, or a lot of things we talked about which we can improve, but really the leverage can be made of what is there in India. So that has given some confidence in terms of people capability. We talked about process needs to be leveraged, and we heard about how empowerment of the people and how encouraging failure early is, and celebrating for the failure for that matter, is going to really be there. Now, so confidence has come, conviction was there at the start, confidence has come with people experiences and discussions and interactions here. Next step definitely is to take the first step. So the first 2 steps of the journey has happened hopefully for all of us here. So we are ready to take the first step. My only sincere request